All right, everybody. Today what we're going to do is we're going to go and look at the next step in chemistry. We were looking at the number of moles. Now, remember, moles, you're looking at how many of something you've got. It doesn't matter if you're looking at atoms, molecules, people, paper. It's a count. So that count, 1 mole of something is going to be that 6 septillion value. And when we want to get the molar mass of something from the periodic table, you simply take, for example, let's just say 1 mole of carbon here. All right, carbon, 1 mole of carbon, you'd have 6 septillion atoms of carbon. On the periodic table, it's going to be 12.01 AMUs, but if you have 6 septillion of something, you use the unit grams. Now, if you have this basic understanding of what a mole actually is, a count, we can relate that to the term molarity. Right? Molarity, you're talking about how concentrated is something. So we have concentration of a liquid in the case that we're going to be dealing with. So a concentration, 2 things you have to remember back when we were looking at the classification of matter. If you have a concentration, a solution is going to have a solute and you're going to have a solvent. So for concentration purposes, when we are talking about a mixture, the lab that we're going to do possibly tomorrow, it depends on whether or not you get all the work done on this. The solute that we're going to be working with is high C fruit punch. Okay, that's the stuff that's going to be dissolved. If we go over to the solvent, in this case, we're going to use in the lab the universal solvent, water. All right. Now, some of you guys like your high C or your drink mix to be a little sweeter. Some of you guys don't. What that is related to is your concentration. The amount, and remember, the term amount refers to moles. All right. How much? How much sugar are you putting into your high C fruit drink mix in comparison to your water, your solvent? So in chemistry, molarity, because we've already used the capital, or we've used the M for other things, what we do for molarity when we're trying to describe it, we use kind of a jagged M like this. All right, this thing right here, this represents molarity. And that is going to equal, well, if we're looking at the amount that we're dissolving in something, like the sugar into your drink mix, that is going to be measured in the amount of moles. Remember, this right here, this is the solute, the stuff that you're mixing in. And we're going to divide it by your liter of solution. All right, this is liter of solution. So let's take this idea right here and apply it to some story problems. All right, what you'll need to have on your screen would be this right here. And I'm not going to leave the next thing up for the whole time. We got to get the right one here. I'm pretty sure it's this one. We'll check. Yep, this is the one that we want. All right, so this is the paper that we want to have open, in addition to the problem page that I've set a lot of it up for you. So if you're following along, this should be pretty easy. Now, question 1, you have seawater contains roughly 28 grams of salt per liter. So that 28 grams is not in moles. Yes, it tells you what your mass is, but it doesn't tell you your quantity. So what we have to do is we want to take that 28 grams and we want to change that to be your quantity, your mole. So you can see 28 grams right here. I have grams right here, so we're going to put 28.0 grams in for your salt. Underneath it, you see the liter. Well, how many liters is it talking about? Right here, it says per liter, so that's just 1. Now, the liters, according to our unit of measurement here, we've got the first part, we've got liters on the bottom, but we don't have moles on the top, and that's what we need. So down here, how do we get moles on the top? Well, you need to get rid of your grams sodium chloride. If you want to get rid of something, you have to cross cancel it. So we're going to put grams NaCl right here. Okay. What you need to do now, this is not something I'm going to do for you. What you need to do is look up what the molar mass of sodium chloride is off the table, add it up, and you're going to put that number right here. To start you out, you have sodium. That's going to be an alkali metal. Left-hand side of the table, 22.99. We have chlorine here. Chlorine is a halogen. It's on the right-hand side of the table. That mass is 35.45. So you got to add up your values, plug that number in right here, and then you're going to take 28 times 1. You multiply stuff across the top, and then you divide it by the stuff on the bottom. And if you end up with a value ending with a 9 right here, you did it correctly. So let's go to question number 2. Question 2 says, what is the molarity, all right, molarity, amount of solute dissolved in a solvent? It says that you have 245 grams of, and this is sulfuric acid. Don't get the stuff on you. If you do, it's going to feel like needles poking at you. You have to use cold, soapy water to get rid of it. So you have 245.0 grams. All right. Now, on the bottom, on the bottom here it says 1 liter. So 1 liter. And yes, we have liters on the bottom. That's what we need. That's perfect. No change needed there. But on the top, you can see that it says grams. We don't want that. So we cross-cancel those units. What you have to do is you have to get the molar mass of sulfuric acid from the periodic table. So hydrogen, there's 2 of them. Each is 101. You have sulfur, 3206, I believe. You better double check me on that. Okay, trying to go by memory. And then you have oxygen. There's 4 of those. Each one is 16. So what you need to do is go through, add all of them up, and then go ahead and do your math to divide it out. You should end up with a 2 right here and some change. Let's go to number 3. You're going to see something just a little different here with number 3. So let's start it out. You put the mass on top. Mass on top. You have, it says 5.3 grams. So we put 5.30 grams. And you notice on the bottom I have milliliters because you don't have a liter of solution. You only have 400 milliliters. So we'll put 400 down here at the bottom. Milliliters. All right, just like before. You have to have moles on top, liters on the bottom. You don't have either one of them. The first one's pretty easy because you've already done this a bunch of times where you have to get your molar mass. So you'll have to add that stuff up off the periodic table. You got 2 sodiums, 1 carbon, 3 oxygen. Add up all that mass, and you're going to put it into the bottom there. The new part, you have to get rid of this milliliters thing. All right, now this milliliters, if you want to get rid of it, you have to cross cancel. You don't just cross cancel down, you can cross cancel up. So I have 1 liter equals 1,000 milliliters. So you do your math, multiply across the top, divide it by both things on the bottom, and then you're good to go. Now, if you struggle with the calculators, what you want to do is take 5.3 times 1,000, hit enter. Press divided by 400, press enter, and then go divided by, and then whatever that value is once you add it up. All right, let's go to number 4. Number 4, you have what is the molarity of 5 grams? So you got 5 grams. Put in 5 grams here. 5 grams of sodium hydroxide in 750 milliliters. All right, so the 5 grams is your solute. That's the stuff that's going to be dissolved. You're going to have that in 750 milliliters. All right, just as normal, when you're looking at doing this, these two values here are going to get cross-canceled. You'll have to look up the molar mass of sodium hydroxide on the periodic table. And then by doing that, that crosses it out, and you end up with moles on the top. We do not have the number of liters on the bottom. See, it says milliliter. So you have to cross-cancel that. And remember, this is just a value you're just going to have to remember it. All right, 1 liter is 1,000 milliliters. Multiply across the top, divide it by the stuff on the bottom, and you're good to go. We have number 5. First thing, number 5, where they have Na2C3. Somebody didn't put the O in there. All right, so there should be an oxygen in there. But I do have that, or I will put that correct on our piece of paper here. Here, we're going to start with something just a little different. See, here they give you the 2 molar solution. All right, now remember that capital M. What does that capital M represent? The capital M right here, that represents this quantity. All right, so keep that in mind. Capital M represents moles over liters. So right here, the best practice that you can do is what I did here. I put down the capital M, but then I wrote in the red what it represents. And you're going to see why we did that in just a moment. It says 2 molar. I'm going to put 2 molar. What does that 2 molar represent? That 2 molar represents 2 mole in 1 liter. Now, why do I have you put this down, or why did I put this down? Because if we have the 1 down here already, that means that this bottom portion already has a number, and you should not put anything else there. There is 1 liter there. So when we go to put in this volume of 10 liters, the question is asking, how many moles do you have? You got to get rid of the liters, don't you? So if you're trying to get rid of the liters, and it's not erasing on me, here we go. If you're trying to get rid of the liters, we cross cancel, remember? So right here, if I need to get rid of the liters, I'm going to put liter up here like this. And I have 10 of them, 10 liters. All right, I hope you don't have to get the the calculator out for this one. That one should be pretty simple. Let's go to number 6. Number 6, remember again, if it says capital M, we have 2 mole per 1 liter. I do not put anything down here because when we say it's 2 molar solution, you are saying that you have 2 moles of material dissolved into 1 liter of solution. All right, now, here's the deal. They tell you that you only have 10 milliliters. So what we need to do is we need to get our unit changed from liter to milliliter. So just like before, we cross cancel out the liter, and what does a liter, 1 liter equal? 1,000. And how many milliliters did they give us? They gave us 10. Right? So you will multiply across the top, divide it by the stuff on the bottom, and you're good to go. With that in mind, number 7 is the similar type of question. So you're going to do that one on your own. Number 8 here. Number 8 says the weight in grams would be contained in problem 7. So you're going to have to use your answer from before to help answer number 8. Okay, so whatever you get from answer number 7 right here, right there, you're going to put that number right here, and then just get your molar mass of salt, and you should have that from, what question was that? That was question number 1 right here. So you should already have that number, and you can just plug it in. Don't reinvent the wheel. Use the number that you already have. 9 is a little different. Okay, 9, you're going to have to find not the number of mole, but you got to figure out your number of grams from this. So let's start off. Number 9, it says that you have a 2 molar solution. Whoever made this up could have had different molarities, but whatever. You got 2 molar solution. That'd help if I was on the right one. That was number 9. Number 10. No, I'm losing track. Yeah, we'll do number 9 here. Since we have number 9, you got 2 molar right here. All right. Now remember, one more time. If you have 2 molar, you've got 2 mole of solute that is dissolved in a liter of solution. What we have to do is we have to change your moles. So 1 mole, you got to get your molar mass of sulfuric acid. You need to get rid of the liter. And why get rid of the liter? Well, right here they tell you have 750 milliliters. You got to get rid of milliliters. So the first thing you got to do is convert it. You don't want liters, you want milliliters. So the number of milliliters that you're given, 750. Okay, you multiply across the top, divide by the stuff on the bottom. Now let's take a look at the new stuff. Number 10, this is a little bit different. All right, this one, instead of you finding the molarity or your number of mole or your number of grams, we're going to look at finding the volume. All right, and trust me, you're going to be glad that I filled this out, because when you are working on trying to find your volume, you have to start with the number of grams that are given to you. See, it's different than the other ones. The other ones you started with your molarity. Here, we're starting with the number of grams instead, and you'll see why. Okay, it's kind of like going backwards is what it is. So if you're going backwards, instead of multiplying, you divide. Well, here, we're going to see that we're going to flip-flop our numerator and denominator for those molarities. We got number 10. If we're going to start with our mass here, see how it's 2.45? All right, well, we'll put in 2.45 grams of sulfuric acid. Now, as always, we want to make sure that we're in moles. So you would want to cross-cancel this value. That means you're going to have to get the molar mass from the periodic table. And again, don't reinvent the wheel. You already have that value from the previous question, right? So just you're going to put that same molar mass that you have here into right here. All right, so don't reinvent the wheel. Just think about it a little bit. We have the next thing. We got to put in that molarity. The molarity is an 18 molar solution, and that is like super, super strong is what that is. Don't get that on your hand. You're going to be getting a nasty, nasty, nasty burn on you. The 18 molar. Now, here's the thing. Like I said that you're going to have to flip-flop the numerator and denominator. Why? Because you right here, you've got your number of mole, right? So to cross-cancel it, mole has to go down here on the bottom. Now, if we put mole over liter, you can't cross-cancel it out because the liter would be on the bottom. That's why we have to take that reciprocal value. We have to flip-flop the numerator and denominator, and that means that we're going to put 18 right here. Right? Now, do we need to put anything up top there? No, because molarity is mole over 1 liter, or 1 liter would be right there. All right? Now, since the problem is asking you not the number of liters, like 10, it says, what's the volume in milliliters? Well, you got to change the liter to milliliter by multiplying by 1,000. Okay. We have number 11. Number 11 is set up. It's actually a little bit easier than number 10 because on number 10 we had to change from the mass to the number of moles. But number 11, you can see they give you the number of moles. So you would just start out with your 3 moles. And then you would have your molarity is 12 molar solution. Well, 12 molar, here's a capital M, 12 molar. What goes on the top? Nothing, because you have the unit already, 1 liter. Once you have your 2 in the right spot, since it's asking for milliliters, you got to put in your conversion to go from a liter to milliliters. All right. 12 and below, those are all going to be repetitive of ones that we've done up here. So if you match up number 12 to one of the ones previous, you'll have no problems with that. 13, 14, and 15, same thing. They're just examples of them. And then to finish you up for today, we have 16A through E. 16A through E is where you need to take and figure out your molarity for each one of them. Now you're going to notice I wasn't as nice on these because if we've gone through all the other ones, you should be able to plug in some numbers and get your values. I'll do one of them here because everybody in the past, they look at question A and they're like, oh, there's got to be more to it. Well, you're figuring out molarity, right? Molarity is moles, 4.67 moles per liter of solution. Well, you've got, what is your number of liters? 2.04 liters. Look at your units. Mole over liter, that's the unit for molarity. You're done. You don't have to do anything extra. That's it. All right. So take your time on the stuff. You're going to be just fine. It's something new. Don't get worked up over it. Just go through the directions that I've given you on the previous ones to help you on the ones that we have left over. And turn that thing in when you're all done. All right? Have a good one.